Hello everyone, welcome back to another SL/HL IB chemistry video, and today we will be looking at structure 2.3, metallic bonding. Let's start with a definition. So, a metallic bond is created by the electrostatic attraction between the positively charged ions and negatively charged electrons within a lattice. Bond strength, or charge density, is determined by the charge of the ions themselves, as well as their ionic radius. A decreased ionic radius will mean that the electrons experience a stronger nuclear charge, so they are more attracted towards the nucleus than, say, an element with a larger ionic radius, where the valence electrons will not experience so strong a force, making this bond weaker. And in terms of the charge of the ions themselves, an ion with a charge of +1 will have a weaker metallic bond than one with a charge of +2, as this +1 will only have one space available to be receiving an electron, creating a single bond, whereas this one over here can create a double bond, which, as we know, will be shorter and stronger. Now let's look at the properties of metallic bonds, starting off with conductivity. So, conductivity is a material's ability to transfer heat or energy across it from one point to another. And this is permitted in metallic bonding due to the nature of metallic or lattices, as they contain delocalized electrons or ions, which are free to move. Additionally, metallic bonds tend to be malleable, meaning that layers can slide over each other and stay solid, unlike our giant covalent structures like table salt and ACl, which, when these slide over each other, they will repel and therefore shatter. Metals, due to the attractions in all directions that can occur due to the delocalized electrons, which are free to move, there will always be an attraction between the layers. In terms of melting and boiling point, these are affected by the strength of the bond itself, which means that therefore a higher charge density equates to a higher melting or boiling point. In terms of periodic trends, or trends across the periodic table, so down the group, or the columns, the boiling point will decrease. And this is due to the increase in the ionic radius, which therefore will give us a weaker metallic bond. Across the periods, or your rows, the trend is not as clear as down your groups, but generally you will see a higher melting point across due to an increased nuclear charge, which will reduce the ionic radius. Now, finally, let's take a look at alloys. So an alloy is a heterogeneous, yep. It is a heterogeneous mix. Put that between those things because it's not quite a mix, but it's a heterogeneous mix of metals with other elements, which can include other metals. And this is done to increase the desired traits or characteristics of the molecule or material itself. So this will oftentimes be done to increase the durability or resistance to corrosion or increase the hardness of a metal, depending on what the user intends to use it for. The main idea behind an alloy is that you will have elements of different sizes. Say we have something like this. As we can see, we've got our larger ions and our smaller ions, and due to the different sizes, these layers will be harder to slide over each other, which therefore increases the durability of the metal itself and makes it less malleable, so more resistant to forces and stress. And some common examples of alloys include steel, which is just carbon and iron, and brass, made of copper and zinc. Now that is all for metallic bonding. Hope that was helpful and that you enjoyed.